Hey guys, Mr. Milton here. Today we're going to talk about inductive reasoning. At the end of this video, you should be able to identify patterns and make conclusions based off of those patterns. And you should be able to provide a counterexample to show a conjecture is false. Alright, so there are two types of reasoning, and we'll look at this lesson. First is inductive reasoning and inductive and deductive reasoning. Okay, we'll focus on the first one, but it's good to know about the second one. And what inductive reasoning does, inductive reasoning makes generalizations or conclusions from specific observations. So, for example, we have George Washington passed away, Muhammad Ali passes away, Michael Jackson passed away. So our conclusion would be all men eventually pass away. Okay, based off of these specific cases, we're seeing some uh, uh, from these specific cases, then we can make this general conclusion. Okay, deductive reasoning makes specific conclusions from broad generalizations. So you'll notice that this is inductive reasoning backwards. Okay, so here's our broad generalization. Every human eventually passes away. Okay, that's a broad generalization. And we say Steve is human. So if every human eventually passes away and Steve is a human, then we can say that Steve will eventually pass away. Steve will eventually pass. Alright? So, in this lesson we're going to focus on inductive reasoning. Okay, the conclusion we made in the example above is an example of a conjecture. Okay, and a conjecture is just basically what we put forward to be true. Okay, so that means it could either be true or false. So we look at specific cases and then make it a generalization. It could be true or false. Proving a conjecture to be true is much more difficult than proving a conjecture to be false. Okay. To prove a conjecture to be false, all you need to provide is one counterexample. Okay, important to understand that word, or an instance where the conjecture is false. So a counterexample is just one thing, one instance, one time where what we thought was going to happen doesn't happen. Okay? So one time where our conjecture is not true, and then that would be our counterexample enough for us to say, okay, it doesn't work all the time, this must not be true. Okay? Okay, so I'm going to have you fill in the counterexample here that all four-sided figures are squares. What you have to do is find a counterexample, a case where that is not true. Okay, let's look at the second conjecture and provide a counterexample here. The conjecture is all non-intersecting lines are parallel. Okay, so if we have two lines and they don't intersect, then they must be parallel. Okay, and we know that this isn't true because we paid attention last chapter and we said, wait, what about those lines that don't intersect but aren't on the same plane? Those aren't parallel. Those are skew lines. skew lines are non-intersecting lines, but they also aren't parallel. Okay, so all we have to provide to show that this statement is not true is one counterexample, and in this case, that's skew lines. All right. All right. So here we go. Let's look at a pattern. Make a conjecture about the pattern in this sequence. It says, and then use your conjecture to find the next two terms. So basically, our conjecture is us finding the pattern. Okay, let's see what pattern's holding up here. So we have 3, 6, 12, 24. What's our pattern? What's our conjecture? Okay, if you're looking at the pattern that I'm looking at, I say, hey, each time we're multiplying by 2. 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24. We should continue this pattern to find out what's going to happen next. If we do that, so that's our pattern, let's establish that. We say each term times 2. Okay, or actually I should say multiply each term by 2. The word multiply needs to be there. Multiply each term by 2. Okay, so now follow that advice. What should the next two terms be? 24 times 2, which would be 48, and then 48 by 2, which would be 96. Okay. Alright, so our next sequence we have A, C, E, G, I. We need to find the next two terms. So looking at these, we might say, okay, how do I get from A to C? What's happening? Well, and how do I get from C to E? I need to find the pattern that works for both of those. Okay, there's a lot of things you could notice. I say, okay, A to C, it's B. A, B, C, D, E, F, G, H, I. So, looks like we're going to skip one letter each time. Okay, we're going to skip one letter each time. And so, in order to get to the next two terms, I want to skip J and get to K. So I skip L and get to M. Okay, and so those are my next two terms. Alright, and so it's all about finding the pattern. Alright, it says this table shows how many regions are created inside a circle when there are a certain number of points placed on the circle. Okay. And so what we're doing here, how many regions will it be created by 6 points on the circle? So what we have is a situation where if we have a circle, we have 2 points, and we're creating lines. How many regions are created? So I have a circle with 2 points. I can show you this. There's a couple ways that we can do this. We can analyze the table, and we can say, okay, and basically find patterns and say, okay, what's the pattern between this way, what's happening here, left to right. We can say what's happening in our each column and kind of recognize the pattern. Or the final way that you can do it is you can look at the actual situations. Okay, so in the actual situations, we have 2 points, we have 2 regions, as it shows here. Okay, we have 3 points on the circle. It doesn't really matter where you put the 3 points, and we connect each line, so or make each little connection between the points. Okay, so we have 1, 2, 3, 4 regions. We have a circle, have 4 points. So connect them all. One, make sure all the points are connected. So I'm going to connect these 2 points. I'm also going to connect these 2 points. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 4 points, 8 regions. I could do the same thing with 5. If I drew a line in between, or point here, drew a line, and counted those new regions, then we'd have 16, okay? Now, it's not going to be easy for us to count all those spaces. You'll notice that those spaces will get really small, those regions will get really small. So this is going to be a lot easier for us to analyze the table to see what's actually happening. Okay, and as I look, I can recognize a pattern here and say, hey, well, these points are increasing by 1 each time. The region is actually doubling each time. Okay, so if I follow that pattern, I can do that here. If I doubled it, 6. If there are 6 points, they would create 32 regions. So there's 2 ways that we could do it. We could keep creating circles and lines, or we could recognize the pattern and make our conjecture about this. Okay. Alright, so for inductive reasoning, we're looking for patterns. We're going to make a conjecture about that, and to prove a conjecture false, then we had to provide one counterexample or one case where it doesn't work. Alright, see ya.